This is Calculus 2 class. We studied parametric equation previous session. Parametric equation give more opportunity to represent different curve. Also, they show the movement of object. Now we're gonna have another way to represent curve. We call polar coordinates. This one is give more chance to sketch different kind of curve and beautiful curve we never imagined with the rectangular equation. Let's just start polar coordinate. So rectangular coordinate we use so far, let's say rectangular coordinate, Gaussian coordinate, we're gonna use x and y. So here is x-axis, here is y-axis, here is origin. We use x coordinate, y coordinate, plot the point. For example, you go to the right, that's the x, go up, that's the y, then plot the point x and y. So there are different ways to represent point on the coordinate plane. We call polar coordinate. Let's just start polar coordinate. Polar coordinate represent point with r and theta, guys. R and theta. R is gonna be first. Let's define the angle first. This one is origin. Then this one is polar axis, usually positive x-axis. And then you find the point here. Rectangular coordinate, we write this one is x and y. Then you draw the line between the origin to this point. Then you find the angle. That's gonna be theta. And distance from the origin, this one is r. You represent this point with r and theta. That's what we call polar coordinate. So polar coordinate is using r and angle theta. That's what we call polar coordinate. Here is very important concept with the polar coordinate. First, you always decide the theta first, here, right there. This point is r and theta because this is positive x-axis. This is line between the 2 points. Then we say this is theta, and this distance gonna be r. That represents this point r and theta. But negative r, meaning is 100 notate the other side. This case, negative r and theta. That's represent the point with negative r. Guys, understand that? One more time. Here is origin. Here is a positive axis. There's a line between the origin to this point P. Then this side angle. Distance between the 2 points, that's gonna be r. Then you rotate this line 180. Then you have negative r and theta. So now we're gonna start with the example with the polar coordinate. So polar coordinate use rectangular coordinate. We're gonna sketch the point or curve of polar coordinate on the rectangular coordinate. First is horizontal line gonna be x-axis. Vertical line gonna be y-axis. This each circle and line represent angle or radius. So first, guys, look at this angle first. So this line represents angle. What is the angle here? Pi over 6. Pi over 4 using middle here between the 0 and pi over 2. This angle represents pi over 4. Let's go more. This one, this line between the initial axis, that's represent pi over 3. like we did in pre-calculus. Now, let's figure it out the radius. Radius represents the circle that's distant from the origin. Let's just start the first one. This one, this circle, all the point here, distance from the origin gonna be 1. So this one is this distance is 1. This distance 1. This one is 1. This is 1. So second one, this one is represent all the distance from the origin is 2. This one is 2. This one is 2. Last one, this outside is this one. All the point here, radius gonna be 3. That's how to use polar coordinate. Let's practice with example. Now, let's have example for the polar coordinate. Polar coordinate, you represent r and theta. So always start with the theta, okay? Let's plot the A. R is 1, theta is 5 pi over 4. We already know this one. This first line is pi over 6. Here is a middle pi over 4. Here is a pi over 3. Here is a pi over 2. Here is, what is here? 2 pi over 3, so on. So we did in pre-calculus. 5 pi over 4 is a third quadrant right here. That's going to be from here to here, 5 pi over 4. Now you find the line for the angle using the radius. Radius gonna be positive, then point is gonna be this line. The radius 1 meaning is distance from the origin is 1 right here. So we find the point A. Point A gonna be right here. That's the point A. You plot the point A on the polar coordinate. Let's go to this time, second one. So this one is theta is gonna be 3 pi. So one revolution, one cycle is 2 pi. So one cycle is 2 pi. You go to the more pi. So this one is this one. They have negative x-axis. Here is r. R is positive. That's represent distance from the origin, 1 and 2. So you have point B value right here. Point B is right there. You plot it. Guys, make sense? Let's go next one. So this one is sketch the angle first. 3 pi over 4 gonna be right here. That's gonna be 3 pi over 4. R is gonna be negative 3 this time. So first you plot the 3. 1, 2, 3. This point represents 3. 3 pi over 4. Now, R is negative. You rotate it 180. This one is gonna be negative 3, 3 pi over 4. Guys, make sense? Now, last one. This one is gonna be, let's see, where is everything here? Now, last one is angle gonna be, this angle gonna be theta. Negative 2 pi over 3. Negative meaning is opposite direction. So negative 2 pi over 3 should be right here. Negative 2 pi over 3 right there. Then we have find the line. That's the angle represent. R is a positive. So point should be this one, this side. So R is 2. That's going to be 1 and 2 right here. So that's going to be D. Everyone clearly understand how you plot the point on the polar coordinate? You probably notice polar coordinate do not have unique representation, which meaning is you have so many different way write the point with polar coordinate. Let's just start this example. So 5 pi over 4, this angle gonna be third quadrant. This is the third quadrant, 5 pi over 4. Radius gonna be 1. You're gonna find the distance from the origin. This is 1. That's the 1, 5 pi over 4 plus this point. Another way represent this point is this angle. This angle is negative angle. Negative 3 pi over 4, radius gonna be 1. Okay? So you have two representation for this point. Another way, you're gonna have one cycle gonna be 2 pi. Then you're gonna go more 5 pi over 4. So 2 pi plus 5 pi over 4, that's gonna be coterminal angle. That's gonna be a certain pi over 4. That's represent angle. Radius gonna be 1. So you have a third case. Now, you sketch pi over 4. That's the first quadrant. This point gonna be 1 and pi over 4. Rotate this point 180, then the opposite side, then radius gonna be negative 1 and pi over 4. So polar coordinate don't have one representation of a point. There is so many different way represent point on the polar coordinate. So here is our equation. Point is represented by polar coordinate and rectangular coordinate, which meaning is rectangular coordinate gonna be x and y, P point, polar coordinate gonna be r and theta. Then how can I convert between two coordinates? So first we're gonna start polar coordinate, r and theta, gonna be change x and y. So look at this right triangle from pre-calculus class. If they give in r and theta, how can find x and y? That's the right triangle. So we're gonna use definition of trigonometry right here, guys. So we know the r and theta, find the x and y. So using this right triangle, then we're gonna use definition of cosine first. Cosine theta gonna be, what is it? X over R. I'm sorry, guys. X over R, right? Adjacent of a hypotenuse. Sine theta gonna be Y over R, right? Opposite of a hypotenuse. From here, you times R both sides, X equal R cosine theta, Y equal R sine theta. So when you give an R and theta, you can find X and Y, this process. Now, when you give X and Y, then we want to change this one is R and theta. So now you look at this one. Now this time, you know the X and Y. You want to find the R and theta. How can find theta is right there. Theta is related tangent. So this one is tangent to theta, y over x. So find the angle gonna be arctangent y over x. That's you're gonna find it. R gonna be distance between 2 points. So 0 and 0, x, y. So R square gonna be R square gonna be, you can use distance formula, you can use Pythagorean theorem. Here is R square, x square plus y square. So R equal square root x square plus y square. So you feel a little awkward, right? I didn't put the positive, negative. When you convert from the rectangular coordinate to polar coordinate, we assume r is positive, theta is 0 and 2 pi. So we're gonna find only one notation for this. Now, first example is we're gonna convert the polar coordinate to the rectangular coordinate, which means they give r and theta. Now they give here r and theta. We want to change x and y, right? Then you're gonna use a right triangle here on the coordinate plane. Here is r, here is a theta. So using the definition of trigonometry, so cosine theta gonna be, where to put the x? Here is x, here is y. X of r. So x gonna be r cosine theta. Sine theta gonna be y of r. So this one is gonna be y gonna be r sine theta. So let's start this one. Here is r is 1, cosine is pi. Cosine pi is -1. Here y r is 1, sine pi. This is 0. So this one is convert from polar coordinate to the rectangular coordinate is -1 and 0. Does it make sense? Let's go second one. R is x equal, second one, R is 2 cosine pi over 3. 2 times cosine pi over 3 is 1 over 2. That's gonna be 1. Y gonna be 2 sine pi over 3. Sine pi over 3 gonna be square root of 3 over 2. That's gonna be square root of 3. So you find the rectangular coordinate for this point. That's 1 on square root of 3. Next example is we're gonna convert from rectangular coordinate to the polar coordinate. Rectangular coordinate give the x and y. So we have to find the r and theta. Let's draw the coordinate plane. This time they give the x and y. Through the right triangle, we find the theta, we find the r. Theta gonna be, we using, here is x, here is y. Tangent theta gonna be y over x. Pythagorean theorem, r squared is x squared plus y squared. I said we're gonna take r is positive, this conversion. R is square root x squared plus y squared. Okay, so let's do this first one. A gonna be x is 1, y equal -1. Tangent theta gonna be y over x. Y is -1, x is 1, that's -1. R square gonna be x square, 1 square plus -1 square. 1 square plus 1 square, that's the 2. R is square root 2. So you have decided theta. Theta is -1 is second quadrant, fourth quadrant. Everyone remember that? But let's plot second quadrant, fourth quadrant. But let's plot x and y. Y gonna be 1 and -1. 1 and -1 is right here. That's gonna be 1 and -1. We're gonna find this angle. So theta gonna be here. This angle gonna fourth quadrant, guys, okay? So this one is 7 pi over 4. So we find the polar coordinate, square root 2, 7 pi over 4. Very careful with this polar coordinate. You sketch the point, then check it out which quadrant should be sketch the point. So let's go to B part. B gonna be R is 0. No, X is 0. So tangent theta gonna be 2 over 0. That's undefined, right? This is undefined. Denominator 0, right? R square gonna be x square plus y square. 0 square plus 2 square is 4. R is 2. Now, you have this side undefined, but when you sketch the point or the coordinate plane, you can find very easily. 0 and 2 is y-axis. This is 0 and 2. So you want to find the angle? That's pi over 2. So what is going to be polar coordinate? R is 2. Theta going to be pi over 2. So when you're looking for the polar coordinate, rectangular coordinate representation, sketch the point and you're going to check where plus point is, then you can find angle and radius very quickly. Next question is we're gonna converting an equation from rectangular coordinate to the polar coordinate. Idea is the same, guys. So this one is x and y, this one. So this one is gonna be rectangular coordinate. So rectangular equation. So we want to change this one in polar equation. Polar equation represents in terms of R and theta. How gonna using? You're gonna using this one. So x is R cosine theta, y is R sine theta. So y gonna be R sine theta, x gonna be R cosine theta. So move the R right there. Sine theta minus cosine theta equals 0. R is 0. That's gonna be origin sine theta minus cosine theta equals 0. Sine theta equals cosine theta. Divide by cosine both sides. Cosine theta divide cosine both sides. So you have tangent theta is 1, which meaning is angle gonna be pi over 4. So that's gonna be polar coordinate. Okay? Another one is x squared plus y squared. You're gonna plug in x value, y value here. R squared gonna be, x squared gonna be r squared, r cosine theta squared, r sine theta squared equal 1. So r squared cosine squared theta plus r squared sine squared theta is 1. Common factor is r squared, cosine squared, theta plus sine squared theta is 1. That's you have r squared. Cosine squared plus sine squared is 1. R squared is 1. So polar equation gonna be r is 1 or r is negative 1. That's represent. This time we have polar equation to the rectangular equation. So what are you going to use? This one is very tricky, guys. What do you know about polar to the rectangle? Gonna be you have this relationship. You know the r and theta. This one changes x and y. We know the r square, x square plus y square. Tangent theta gonna be y over x. That's all information you have. So first one is you have to using this one, guys. Look at this. R is 2. R square. So we're gonna square both sides. R square, 2 square. 2 square is a 4. R square is replaced by the x square, y square. So this one is x square plus y square equals 4. That's you're going to convert from the polar equation to the rectangular equation. Same thing is here, guys. Look at the theta is pi over 3. Theta is right there. So we're gonna plug in the theta in tangent. So this one is a tangent. Theta is y over x. Theta gonna be pi over 3. Tangent pi over 3 is y over x. Tangent pi over 3 is square root of 3, y over x. So you have a rectangular equation, y equals square root of 3x. Everyone understand a little bit about the conversion from the each coordinate. Let's practice more conversion. So here is two more examples from the polar coordinate to the rectangular coordinate. So I'm going to write the conversion formula right there. First one is r squared. R squared is x squared plus y squared. Tangent theta gonna be y over x. That's gonna be conversion from rectangular coordinate to polar coordinate, right? Then this one is, another one is x equal r cosine theta, y equal r sine theta. This one is polar coordinate to the rectangular coordinate. So we're going to using this conversion formula to change this equation. So r is for cosecant theta. They have only cosine and sine. Let's change this cosecant by use the identity. So this one is r equal 4 over sine theta. So everyone remember that, right? Cosecant theta gonna be 1 over sine theta. So I times the sine theta both sides. R sine theta equal 4. We have to find the rectangular coordinate, but look at this. Here is r cosine theta is x. No, r cosine theta is x, r sine theta is y. This one, plug in the y value equal 4. That will change this equation. Let's practice this another one. This is more challenging a little bit. So you look at this. R is 2 cosine theta. So we want to convert. We need r cosine theta or r squared. So you're going to pick the one of them. So I'm going to do times r both sides, r squared to r cosine theta. So here is r cosine theta replaced with x. That's the 2x. R squared gonna be replaced x squared plus y squared. So you guys remember from pre-cal algebra, this one is x squared plus y squared minus 2x equals 0. X squared minus 2x plus y squared equals 0. Let's make complete square. You need here x squared minus 2x plus 1 minus 1 plus y squared equals 0. This part gonna be complete square. X minus 1 squared minus 1 plus y squared equals 0. So this represents x minus 1 squared y squared equal 1. That's gonna be circle with center gonna be 1 and 0, radius gonna be 1. So that is this polar coordinate represents a circle with the center is 1 and 0, radius is 1. Okay? Now we practice conversion. Now we're gonna sketch polar coordinates. So let's just sketch the r equal 2. How can sketch r equal 2? You can use conversion to have rectangular coordinates. This one is another way. This one is we have conversion to the rectangular coordinate. This one is gonna be x squared plus y squared is 4. Another way that represents center is 0 and 0, radius is 2. So you're gonna have, here is this graph. That's the one way you sketch the polar coordinate. But this one is, it doesn't work all the time. Another way you understand this graph, guys, let's see where is it. How gonna sketch this one? Let's thinking about theta. So here is gonna be theta. Here is R. Theta 0 is 2. Theta is pi over 2 is 2. Theta is pi is 2. Theta is 3 pi over 2 is 2. Theta is 2 pi and still 2. Which meaning is, let's plot it. 0 and 2. Theta is 0 is here. Here. Positive x-axis. Radius is 2 right here. Theta is pi over 2 is right here. Radius is 2 right here. Theta is pi here. Radius 2 is here. 3 pi over 2 here. Radius is 2. So you have circle. That's how to sketch R equal to. How about this one? Second one. So theta is always pi over 3. R is keep changing, guys. Theta is pi over 3. I'm gonna sketch the pi over 3 right here. This is pi over 3. They don't have R, any R value. So this one is represents theta is pi over 3. R can be negative. That's why 180 rotation. This line. This one is theta is pi over 3. Previous example, we changed this one is rectangular coordinate y equals square root of 3 over x. Exactly, they showed this one. This is a straight line which path through the origin. Here is a slope, square root of 3. But at the same time, in the polar coordinate, theta is pi over 3. Let's sketch the polar equation r equal to cosine theta. So how gonna sketch it? Let's have this table. So let's start. Theta is 0, pi over 4, pi over 2. This angle gonna be first quadrant. Then we're gonna calculate r to cosine theta. Theta is 0, r is 2. Theta is pi over 2, r is 2. Cosine pi over 2, 4 is square root 2 over 2. That's going to be square root 2. Theta is pi over 2, r is 2. Cosine pi over 2 is 0. That's going to be 0. That's the first quadrant. So I'm going to sketch it. Theta is 0 and 0. R is 2. That's gonna be right here. Theta is pi over 4. This line, square root 2 over 2. That's gonna be probably right between the 1 and 2. Pi over 2 is y-axis. R is 0 is right here. So I sketched this one right here. This part. Does it make sense? Now, second quadrant. So second quadrant gonna be, what happened, guys? Second quadrant theta. So that's gonna be 3 pi over 4. I'm gonna write here 3 pi over 4 and pi. What happened, guys? 3 pi over r. 2 cosine 3 pi over 2, 4 gonna be negative square root 2. That's negative square root 2. Theta is pi, r is 2 cosine. Pi gonna be negative 1, negative 2. So 3 pi over 4. 3 pi over 4 is right here. So then R is negative. You are not sketchy here. You have rotation 180. So right here. That's gonna be here. Pi, you're gonna have this negative x-axis. R is negative. So right here, but rotate 180. So right here. So you're gonna sketch this one. Everybody make sense? Now, this one is, let's say, quadrant 1. This is quadrant 2. Let's go third quadrant. Let's do the third quadrant, guys. The third quadrant is, let's just sketch 5 pi over 4 until 3 pi over 2. That's gonna be quadrant 4, quadrant 3. Quadrant 4 gonna be 7 pi over 4 and 2 pi. All right. Theta gonna be R is 2 cosine theta 5 pi over 4. That's gonna be 2 times negative square root 2 over 2. That's gonna be negative square root 2. Cosine 3 pi over 2. That's gonna be 0. 2 times 0 is 0. Let's sketch that one. So pi is, we sketched this point. Now, 5 pi over 4 is right here. Right here. Negative square root 2 is right, but this one is negative. So you have 180 right here. So this one, so what happened here, guys? Go here, that's quadrant 1 graph. Here is quadrant 2 angle. Quadrant 3 go to same thing. Here is quadrant 3. Here, then go here, that's this point. Then 3 pi over 2 go to the origin. Okay? 7 pi over 4 cosine R is 2. Square root 2 over 2, that's the square root 2. 2 pi is cosine 2 pi 0, that's the 0. So what happened is quadrant 4, R is gonna be square root 2. Angle is 7 pi over 4. Angle is 7 pi over 4 is right here. This is 7 pi over 4. Square root 2 is right here. Go back to here. Then 2 pi's go back to here. So this one represents polar equation. So you're thinking about the repeated sign value, and the positive, negative depends on coordinate plane. You can sketch the polar coordinate easily.